Hey, it's Patty. I'm going to take some time in this presentation to redefine what a connective tissue disorder is. This is extremely, extremely important to understand whether you are a provider working on somebody with a connective tissue disorder or are an individual dealing with a connective tissue disorder. This is information that I think is pertinent to being able to help these individuals, and it's really lacking in the availability of the description of what's happening. And it is a really complex topic. So hang with me. But this is so important to understanding why individuals aren't doing well, especially systemically, or that snowball of diagnoses, that domino effect that happens. I'm going to explain that. For some people, actually quite a few people, it's because there's an extracellular matrix dysfunction, which is HSD and EDS. We know this, it's defined. So, what is a connective tissue disorder? Well, for a long time, I think that a lot of people thought it was a hypermobility problem. And I phrase it that way because I hope it was a while ago that people thought it was a hypermobility problem. But I know that there's still people out there that are hyper focused on, well, it's a collagen problem, so it's my ligaments. And that might be true, but connective tissue runs throughout the body. And I think we have more understanding that that is happening, but I actually don't think that even our providers quite understand what they mean by that. So that's why we're going to dive a little bit deeper into the understanding of what are we saying when we say that, like, oh, it's all the connective tissue in the body. Well, what does that mean for the individual? And this is where, if we could understand what it meant for the individual, that we would have more tools and more understanding as to how to help them from the idea of health and homeostasis. And then we can be more precise with, treating a shoulder or treating something specific. But for a lot of people, it gets too confusing because you have that domino effect. And I will hopefully explain that for some people today. Collagen is something that we do talk about with connective tissue disorders. And for some people, collagen is affected. Actually, quite a few people, collagen is affected. And I do understand there's a lot of variants of unknown significance. We'll get there with understanding the phenotypes of the presentation that we have, depending on the different collagen variants. But collagen in and of itself is the kind of the structural component. It is the scaffolding. If we think of a skyscraper, it's the iron or the steel support structures that are holding up that skyscraper. These collagen or steel pieces should be, stable, and they should be able to bear weight and load. So if you have a connective tissue disorder that involves collagen, then perhaps the collagen is made a little bit differently. And instead of having support beams that are made out of steel, it's support beams that are made out of some sort of rubber composite. So collagen can be affected, but important to understand as we go through talking about all of this, that collagen is a big structural component to holding up the 3D matrix that we'll talk about. And that's why understanding the matrix piece is helpful to understanding the ligament and tendon and those 3D structures as well. Okay. But there's a lot of other components in the extracellular matrix. All right. So, and I think this is why it's so difficult to find that gene for hypermobile EDS or HSD, is because, as you'll see, there's so many components of the matrix, and this is a dynamic system, and there's a lot of things that actually contribute to the health and stability and the 3D nature of the matrix, that it's really hard to tell what might be causing the problem for a person. And this just shows, this is from the EDS Society. And this is what we know right now with the genetics, right? So you can see there's a bunch of collagens in there. That's what col5A1, collagen type 5, col1A1, we have col12, col3 is vascular. So there are different types of collagens that have been identified as contributing to the presentation of these connective tissue disorders. But there are other things like glycoproteins and things like that that can also cause changes, or proteoglycans, and how they help to with the alignment of those collagen fibrils that are in there. So there are other things that can affect the 3D nature. We talk about kallikrein, and kallikrein can actually cause the breakdown If we have an uncontrolled inflammatory process, it can break down the extracellular matrix. So it's kind of like as we talk, like the chicken or the egg for some people. Some people can be born with collagen problems or proteoglycan, which one of those is decorin related to MTHFR. So again, there's so much, and this is why science will always prove and disprove because it depends on the person that's sitting in front of us. And this is a really complex topic. But collagen could be the problem. It could also be something else that goes into building proteins, building other structural components that are in that 3D space. Now, just going back to connective tissue in general, just from, I call it one step back from the matrix. The idea that it's not just hypermobility, but it's connective tissue. It's a good start because we know that connective tissue, as we've defined it, um, it could help package and compartmentalize, so it helps separate and organize our tissues in the body, right? It also aids in protection, defense, and repair. And this is really important, this topic, for a lot of people, because it is our barrier mechanism, our filter process, which I'll go into more detail by explaining what the matrix does. But I think a lot of people forget that the connective tissue basically dictates the individual's homeostasis, health balance, what they look like as a healthy individual. This is connective tissue, so I'll explain a little bit more about that. Insulation, adipose tissue is actually considered a connective tissue in and of itself. Fat cells is also an immune cell. I'm not going to go down my rabbit hole of weight problems and autoimmune or immune system deficiencies or disorders that can change fat cells. But that is a thing for those that are out there and struggling with weight management, is that sometimes it can actually be related to immune system responses and not necessarily calories in and energy expenditure out. And transportation, movement. And we're going to talk, this definition is talking about, blood moving, blood carries and transfers. Actually, the extracellular matrix is kind of like the superhighway of communication in the body. It takes away from the cell theory of, it's the cell and the cell determines. Actually, it's the environment that determines the cell. And that's the extracellular matrix. There's actually quite a bit of different types of connective tissue out there. And that's where hopefully I'm going to start to pull people away from ligaments and tendons and realize that there's other connective tissue that's in the body, right? We actually talk about this dense regular connective tissue a lot. That's tendons and ligaments. And dense irregular, I feel like we're starting to talk about a little bit more of, the lining of the digestive tract, some fascia that's in the body. And then we look at connective tissue proper, loose connective tissue, reticular, and adipose. So basically these different linings or support structures throughout the body. And then we have specialized connective tissue like cartilage, bone, and lymphatic tissue. What's important is to start to understand, wait, what makes up this connective tissue? Is it all the same stuff? Like, does somebody that has a collagen type 1 have an issue with all of these things? No, it depends on their genetics or what has happened to their extracellular matrix or their connective tissue through dis-ease processes or inflammation or breakdown. So this is actually, this is a great little infographic from Leslie Russick, who put this all together, again, trying to pull in, like, what are all the systems affected? What do we see that's affected? And there's a lot. And I think this is where things got confusing and also validating for a lot of individuals when we said, hey, people with connective tissue disorders have all the things in all of the places. Well, how's that possible? And it's because we actually already have the definition. It's very hard to understand. So fingers crossed, by the time that you finish watching this, you understand a little bit more of what's happening. But the connective tissue is part of all of these different systems, but it's different types of connective tissue. Okay, it's not just ligaments and tendons. We have all of that reticular type of, or loose connective tissue that's throughout the body as well. And our neurological tissue is lined with connective tissue, and the nerves and the spinal cord and the brain itself, all lined with connective tissue, different types. Okay, but that's what, like, it's everywhere in the body. So that's why we do get symptoms that could pop up everywhere. It's because of the extracellular matrix um, I would say theory. It's not a theory anymore. We actually know, like, this is actually what's happening in the body when we're talking about chronic health issues, even local health issues, like local orthopedic stuff, which we will talk about as well. So this, I think, is so important. It doesn't have all the types of connective tissue in this article. I wish it did. We don't have all of it. So sorry. We don't have blood-brain barrier and things like that we'll talk about. But I think this starts to show us we need to look at this in a different lens. Okay. So if we're talking about an individual that has some sort of um, connective tissue disorder, we're talking about them having a change in the structure of the extracellular matrix. And that doesn't necessarily tell us, oh, do we have a collagen type 1, or is it a decorin, or is it a collagen type 11? What might it be? And there's a crossover. So the way I describe the extracellular matrix is this is pretty much kind of where all the tissue of the body comes from. And as the body is developing and figuring out what's going to be fascia and what's going to be a lining for, the nerves or the blood vessels, or what's going to be tendon or ligament, it's determined by if we talk about like ingredients going into a bowl, if you were making a recipe. So what's in the bowl is your extracellular matrix. And depending on the ingredients and the ratio that you put in, you might end up with muffins or scones or cupcakes, and they all taste very different. So that's kind of what I think about with the matrix is the more important thing is to actually understand the composition of the matrix and understand if somebody has a collagen type, 2 problem, that they might have more of a cartilage type of presentation, but then there might be other supportive structures that are involved as well. Or those that have um, collagen type 1 problems, they might have more of, yes, the ligament and tendon, but look how much that's actually the blue on the bone down on the bottom. You can see how much is in ligament, but there's a lot of collagen type 1 in the bone. And then as we're going to talk about more importantly, well, these are tissue structures, but what about the interstitial space that makes up the extracellular matrix itself? Which is the space where all of our cellular function is. It's kind of the in between, but this is a space. It's the interstitial space. All of our cells are supposed to be moving freely and communicating with each other. That also has a recipe to it. And in the interstitial space, we'll look at it in a moment, but collagen type 1, 2, 3, 5, and 11 play a role in that. So we can't forget about the other part of the extracellular matrix, which is actually what really there's scientists feel like, hey, this is actually the communication hub of the body. This is actually an organ in and of itself. And that work was done in the 1900s, early to mid 1900s by Alfred Pischinger, who wonderful book out there about the extracellular matrix and ground substance that really explains how this extracellular matrix causes cell communication throughout the body, and how if something happens to a blood vessel down in your foot, that you might have compensation to help it temporarily, hopefully, in other parts of the body. So it's actually really a whole system. It's a whole organ throughout the body of this communication hub, and the 3D structure of that space is also supported by some of these things like collagen and proteoglycans and other components that are supposed to be holding it up to be nice and sturdy and allow movement through the space. Okay, so this is going to be fun. Don't worry. What is the extracellular matrix? I think it is just fabulous and exciting once we actually understand what this is, actually for all types of chronic inflammatory conditions, chronic diseases. There's usually a dysfunction happening at the extracellular matrix, whether it's from genetic components or it's been caused by other things that happen to the individual. Okay, so again, it's this 3D structure, right? And it's the 3D structure is held up by certain things like collagens and proteoglycans. Those are the stabilizing pieces of it. But then there is a world of things that exist in the extracellular matrix. And I think it might have been Pischinger that talked about it, like the ocean. There's a lot of things that go inside, but really the ocean space is the extracellular matrix. And the way that he described it, there's a load of information in this book that he wrote before he passed. But as he says, it's defined as a functional unit consisting of the capillary bed, connective tissue cells, and the autonomic nerve endings. And I think that's really important. And there's other things actually that are in there too, like the capillary bed, that's actually talking about our blood vessels, autonomic nerve endings, that's our autonomic nervous system, so dysautonomia and POTS and things like that. This is really important because when you look at this here, and I'm going to bring the immune system into it as we talk, you can see, wait a second, that's kind of like, it's describing the things that we see in people with connective tissue disorders. Yes, that's because we've actually defined EDS and HEDS as a dysfunction of the extracellular matrix. That's the definition of it. So it's out there. We know that this is what it is. It's a little bit confusing to understand unless you understand the work of Pischinger and those that have come after him that are looking at the extracellular matrix and what we call interstitial stasis, which we'll have fun talking about too. But again, the things that we see like I said, collagen is in there in the extracellular matrix. There's electrolytes, glycosaminoglycans, proteoglycans, glycoproteins, polysaccharides, elastin, other proteins. So many things that could cause problems of the extracellular matrix. Like Marfan's has the connection with elastin, and that's how that extracellular matrix problem happens. A lot of people have these, variants of unknown significance with collagen. If you look for a collagen variant and it's like, well, yeah, but it's not exactly classical EDS or it's not exactly arthrochalasia EDS. And we just don't know. And I'm hopefully going to make it more complicated too. We just don't know if you have that particular collagen variant, or whether it's the MTHFR for decor instability as a proteoglycan, we don't know what it's going to look like in you versus somebody else because there's so much else that goes into genetic expression. That's why, like, I focus on the extracellular matrix. That is my happy place. And if you understand that extracellular matrix dysfunction that's left untreated, that leads to interstitial stasis, will activate genetic expression because of the dis-ease and the altered homeostasis in that area, then we don't really need to talk about it. We just know, hey, if you have a collagen, especially people who pop up with multiple ones, so you have a collagen type 1 and 5 and maybe 11 in there, then, well, gosh, that's the interstitial space. Or maybe it's a collagen type 4, and gosh, that's a barrier problem that you might have. That's how I look at it. I just want to know what the structure is that's affected, and then it makes much more sense as we understand what happens inside the matrix. And a lot happens inside the matrix, like all of the things happen inside the matrix. So, yes, collagen is the main structural stabilizing component in the extracellular matrix, but when we look at loose connective tissue, it's actually proteoglycans. Okay. So again, it's just knowing if you're going to start to play with genetics and looking into it and what you might have, then we want to make sure that we know, based on what your genetics have shown, what the tissue is that you might have more issues with, and where we should be looking for signs, symptoms, and then to offer support, right? Depending on the density of the connective tissue, so in other words, the ingredients that have been added to the recipe, we're going to have a different look to that connective tissue. It's supposed to help us with tensile strength, so basically the integrity. It's supposed to help us regulate cell adhesion, right? This communication of how cells are interacting with each other. It's supposed to support chemotaxis, or how the cell reacts to chemical stimulus. It's supposed to encourage cell migration appropriately. It's supposed to allow for movement of those cells into areas where those cells are needed to carry on their process. And it's supposed to facilitate tissue development and healing through all of those things that happen in inflammatory mediators, and a space where the inflammatory mediators have room to move appropriately, right? So that's depending on the density of the connective tissue. Well, what if somebody already has a connective tissue disorder, or collagen variant or whatever it might be, they might be more prone to having difficulty managing these things without additional assistance. It does act as a mediator for ions and molecules that pass into and out of the cell. So again, it's the space around cells, right? It helps support the area around cells so cells can do what they're supposed to be doing. It has to do with the responsive stimulus. Again, like what is sensed in the matrix itself relays that message. I mean, if you were in a dirty pool, then something that's that's down further stream, that you're going to find out that the pool is dirty. And that's actually what the extracellular matrix does. If we have, again, like the blood vessel example, if we have a blood vessel that's irritated in the leg, then it lets the rest of the extracellular matrix know, hey, we have a blood vessel problem. Everybody step up. This is what we've got to do. We're all going to remain a little bit hypersensitive because we don't want more injury, which is not necessarily the snowball effect that we want to see, but it does happen because these are alarm bells telling us that there's something that we need to help or assist in the body. We just need to learn what those things are, which is extremely difficult. I'm not trying to simplify this, but just understand that there's this communication, not just locally from cell to cell, but this communication of the health of the matrix as it's one organ throughout the body, this interstitial space that's talking to other places. Um, it is responsible for cell nutrition. And this next piece, I can't emphasize this enough, and we'll go down not a big rabbit hole, but it's about the inflammatory process, right? So this area, this interstitial space is responsible for the elimination of waste and toxins. And that is so important. And this is where we can argue with the amount of inflammatory issues that we have currently that have gotten progressively worse. Understanding that the extracellular matrix is the 3D structure that is responsible for cleaning this stuff out. And if somebody is born with a 3D structure of that matrix that might be at risk to failing earlier, requiring more help, however you want to phrase it, it's just not as efficient. Um, with our world of more inflammatory things that get into our body, this is where we can argue, and doctors are like, I'm so sick of hearing this EDS diagnosis. It's like it's the new fad. Everybody wants to be diagnosed with it. Actually, people might already be carrying the genetics. We might just be activating them so much more because of the inflammation. And what's important about that is not thinking that we're going to continue to go down this rabbit hole of, oh my gosh, everybody's going to be affected by this. Actually, if we start understanding that it's inflammation that's added to a dysfunctional matrix that can't handle the load, we start working with people individually, everybody's different, about how to handle the inflammation that's coming into their filter system that doesn't know how to help it without help. So, so yes, it seems like more people are being diagnosed with this, not because more people have the genetics, but because we're challenging more people's genetics. Okay, so, and it's the inflammatory process, whether it's local or systemic, that is activating these things to happen, or locally, like within the extracellular matrix, it's causing that inflammatory effect that it eventually will go too far, and the lymphatic shut down, and the body can't keep up with clearing the toxins because too many things have walked into that skyscraper building that's made out of rubber support. And if you visualize that, if you keep adding more and more people, and maybe some of them are, running around and banging up against walls and, doing crazy things in there or trying to light walls on fire, or it's just, it's chaos. If you're adding chaos and more people into a skyscraper that's made of structural supports of rubber, just envision what that might look like. Eventually, it's just going to not work, right? So that's what we have to understand how to work on the stuff that accumulates in the extracellular matrix. And I know it sounds daunting, like, well, we've dug ourselves a hole with all the inflammation that we've brought into this world. Yes, we have, but there are ways to personally work on ourselves, right? So specifically talking about like, well, what inflammation are we talking about? Well, this is where it comes down to individualized medicine. Okay, so it's not necessarily biased, right? I know that there's a lot of providers out there that get hyper focused and say, no, mold is the problem. No, I'm a Lyme specialist. Lyme is the problem. Well, with these individuals, it's actually the extracellular matrix that everything is in. So we don't necessarily want to point a finger at one thing because it can actually be physical type of reactions, inflammatory reactions, chemical, biological, electromagnetic, and psychological as well. Okay, so um, this can be worked through. It's just really about sitting down and continuing to go through layer by layer with the individual as to, okay, what has built up this process for you. But we don't give up, right? If working on mold doesn't get rid of everything, we understand that's only one thing that's swimming in that clogged pool. We've got to look at the other things, the other pathogens and other inflammatory mediators that might also need support. So I I get excited when I meet somebody and like these things haven't been tried, right? And I know it from the other side, they're like, oh my gosh, I have to work on how much? That's why we need more people to understand that it's probably all the things. When the scales have been tipped, it's that bucket analogy, right? This bucket has been filling. The last thing made it overflow, which it might need a lot of help with, right? Whatever that last thing was. But there's other things in the bucket that we're going to have to clean out if we've tipped the scales and the tipping of the scales with a lot of, we'll talk about this in just a moment, but that seems to be pushing towards, yes, systemic issues, and we start to see ME and or chronic fatigue syndrome, myalgic encephalitis, and things like that. And then so you push past that, and we start to spread the inflammation that will start to change the extracellular matrix structures around structures that we don't want changed, like blood vessels and neurological tissue. And then we end up with really, really complicated looking symptoms everywhere, compression everywhere, neurological thing, like all of the neurological things. That's because the extracellular matrix is one system, like the fascia is, but this is actually a different part of the extracellular matrix. The fascia is one part of the matrix. It's one component of it, but this, we forget that there's this interstitial space. It all talks to each other. So just I'm just like to throw science out there. So we know that we're all still talking about the same thing. We're on the same page. Um, there's a lot of inflammatory mediators that exist in the extracellular matrix that we actually use for communication if they're functioning appropriately, right? Prostaglandins have to do with blood flow. Cytokines have to, and they do lots of different things, but this is just kind of like a little summary and it's a bullet point, right? Cytokines work with immune system regulation, lymphokines, immune system as well. Neuropeptides, nerve communication, and proteases break down proteins. There is so much regulation and homeostasis that occurs at the cellular level within the matrix. So that's why understanding extracellular matrix dysfunction is connective tissue disorder. So when people come into me and they're like, "Oh my gosh, my hormones are off," and I'm like, "I bet," or I'm whatever the blood test results show, I'm like, "I bet it's the extracellular matrix that's dysfunctional, and it causes so many communication problems in the body." So you can't really necessarily work on specifics, and I argue that because if we need to work on symptoms, we need to work on symptoms, right? I'm all for symptomatic treatment, but the long end game of understanding this condition is working on stabilizing the inflammatory reactions within the extracellular matrix so that the communication is better throughout the body. So this is, I'm not going to go through all of this, don't worry. But I love visuals, and I really I've had a couple, but we need some visuals right now, right? It's so confusing. So it does look like a hot mess in there, but it is it's organized chaos, and it's actually not chaos. I sometimes I give the analogy of if we're talking about a pool, this is like the Olympic synchronized swimmers, right? It looks there's so much going on inside the extracellular matrix there's people tossing people in the air, but they're like coming back together and they can make these support structures and they can, stand up and lift everybody out of the water and they go down under. You watch the camera and there's so much that happens and they make it look beautiful. But when you watch closely, there's a lot of crazy stuff going on and it does look a little bit like organized chaos. And that is the extracellular matrix, right? So there so much exists inside this matrix, and it depends on where we're talking about, what part of the body as to what is denser or happening inside the matrix. This one in particular shows you the bottom layer there is actually perineuronal nets. So this is looking at something that is next to and talks to the neurological system. Very important to understand. And then we have those little green alien cells, our microglia. So for those that have listened to some other very long-winded things that I've put out there, astrocytes and microglia are really important to understand when we're talking about inflammatory control within the matrix of the neurological tissue. And we'll briefly talk about that. I won't go down that rabbit hole too far, but it's important to understand, it's when we're talking about the conditions that are starting to pop up with HEDS and HSD that look very severe in their presentation, that we might be able to continue to come back to this idea of, well, it's a matrix dysfunction and there's an astrocyte and microglia overload and inflammatory overload within this tissue. And that looks like this at the spinal cord, and that looks like this at the perineuronal nets. Just depends on where the inflammation is happening. Lung tissue, if we're talking about COVID responses, and even possibly the fibrous tissue around the heart with COVID as well. So inflammation can change the connective tissue, the extracellular matrix structure. It can cause this breakdown cycle to happen, right? And those that are born with an increased risk of already having a dysfunction, when we add pathogens to it, it's like lighting a fire. I really like this little graphic here. And this is so important, right? To understand connective tissue disorders, you have to understand where the extracellular matrix structural components are. Because we're saying with connective tissue disorders that there's a loss in integrity of the structure itself. Well, this in-between space, we think, oh, it's just the in-between. That also needs to have good structure so that all the cellular functions happen appropriately. They swim through, they do what they're supposed to do, they have lots of room, they can talk with each other. What's so important about this slide, and this is the conversation I love to have with people that might have their genetics back, and so I'm not saying that we diagnose anybody, but just looking and understanding that if we're talking about, okay, let's talk about the bottom first, the barrier that cell membrane, right? So the barrier, the basement membrane system, the protective basement membrane, the structural components are collagen type 4 and 7. We have some proteoglycans and some laminin as well. Might be important to understand for somebody that you're working with that might have a collagen type 4 or 7 problem is that we might have more of a barrier structure problem. The pericellular matrix is kind of like the mechanical loading space in between. I'm not going to throw this one out the window. It's just not necessarily something that we see a lot of issues with. We could, but this interstitial matrix is, we do tend to see a lot of things happening at the interstitial matrix. And what happens here is what's called interstitial stasis or extracellular matrix stasis. So this is the area where we are supposed to have all of this room. It's supposed to be this nice supported area for all of these cellular functions to happen. And that's collagens type 1, 2, 3, 5, and 11, and some proteoglycans. So so we can understand here, again, if we think collagen type 1 has a lot to do with tendons, ligaments, and bones, it does. And also it can really affect somebody's ability to maintain homeostasis because it's one of the major supporting structures for this interstitial space. So just to understand that it's more than just tendons and ligaments like this. This is our organ system of the body that's supposed to be communicating homeostasis throughout. this is just a depiction of, if anybody wants to read this article, it just talks about the extracellular matrix breakdown that happens with COVID. So just an example, the left side, I know it's probably, if you're not used to looking at pictures of the extracellular matrix, it probably looks like a mess on both sides. The left side is actually a healthy side. That's what the matrix should look like. And on the right side, they just show you the process of what happens of these inflammatory mediators actually going around. And you can see that there's collagen degradation that happens. So a lot of times when inflammation occurs through the release of MMPs or matrix metalloproteinases, which I think I have a slide on here, and we'll talk about, you get a breakdown of collagen. Okay, so that's where we end up in a self-perpetuating cycle, is that the inflammation in and of itself can actually start to harm our extracellular matrix. And if your extracellular matrix already has impaired efficiency, it can do this faster and cause more of like, I don't want to say permanent, because it's not if we can actually get to it, but really this shift into a stuck phase or stasis, right? They actually call it stiffness. Okay, so this is important work that Tina Wang has done, and I'm so sorry I don't have Brian Tuckey's work on here, just because it's not necessarily specifically talking about those with connective tissue disorders, and that's what Tina Wang has been looking into. But to talk about this stiffness and stasis, and what I'm talking about is from the interstitial space. So the part of the body that's supposed to be always communicating like fascia, um, it's just different than fascia. However, Tina has been working with fascia and proving that this is an issue in individuals. So the first work went out and said, hey, there's something different basically with people that have connective tissue disorders or HEDS. There's something different with how trigger points are being found in those with HEDS. It looks different. The way that the fascia is responding is different. So that's very important. Different. That's all that we need to know. Great. It's different than, the extracellular matrix responds differently because it already started off being different. And the fascia does, and that's what she looked at. And then the next one was going into the iliotibial tract, so that sheet of fascia that's on the outside of the upper leg. And when she looked at this, she did find that there's a bias towards stasis or stiffness that occurs in between these layers compared to somebody that doesn't have HEDS. So this is where we've got to let go of the hypermobility piece and just understand that there's a connective tissue dysfunction. Because if it happens, if you have altered collagen in ligaments, you like from like an everyday presentation, you might see that the person has stretchy ligaments, but from the rest of their body, it's not necessarily stretchy. When you add inflammation, you get stasis. And those individuals can talk about the local musculoskeletal orthopedic part of it. That's actually what Brian Tuckey talks about in the general population, that trigger points are actually extracellular matrix stiffness and interstitial stasis. And that article is out there, TUCKEY, if you wanted to look it up. That's what's happening when somebody has this pain and dysfunction, is that inflammation has built up and can't find an exit strategy. So it causes stasis in the local tissue. Okay. And that's what Tina has proven, is that it's more so in this population. We're seeing more of this. And now, if you understand that that's because the extracellular matrix, where the flow is supposed to be free to move through, it's a different structure than somebody without a connective tissue disorder, that we might be more biased towards stiffness and stasis in this space. That's talking from a musculoskeletal fascial point of view. I'm talking from the big systems communication point of view. So it's the same conversation, it's just parallel, but we have to understand that this is actually what's happening at other tissues as well. So what we're actually seeing is a stiffness problem in those with connective tissue disorders if inflammation is not taken care of appropriately. Okay, I have so many slides left, and don't worry, I think that we've covered quite a lot so far, but there's just some points that I want to make, and the science is on here for people that want to go through this. It's important to understand that depending on what part of the body we're talking about, we're still talking about extracellular matrix. The brain has its own extracellular matrix. okay, with collagen and other components, just like other extracellular matrix in the body. All right. The blood-brain barrier might be more easily compromised in some individuals with which HSD and EDS. And just to go back to that, if we look at that blue picture, that shows you, the different layers, the interstitial space, and then the basement membrane. This is the chicken or egg scenario, right? So I'm not trying to complicate it, but I just want people to understand that if you have a problem with collagens type 1, 2, 3, 5, and 11 that causes difficulty in clearing out inflammation in that space, over time, that will actually start to communicate differently with the basement membrane, and it can cause a change in permeability from inflammation in that space. So it's not directly an extracellular matrix genetic problem with the basement membrane, but secondarily, you can develop a change in permeability of those basement membranes, including the blood-brain barrier. So you can also have a direct problem with your basement membranes from collagens or, laminin or something, proteoglycans at that basement membrane that makes you directly more prone to having things possibly irritate and cross the barrier. So just to understand, the barriers can still be broken through other means rather than direct problems at the basement membrane structure itself, if we're talking about those components and ingredients that go into it. So I just think it's important at some point to understand, are we dealing with a barrier problem versus an inflammatory problem or both? Because it just helps us provide better care for the individual for long-term management that they carry on after they work on all of this. Okay. So we talk about the interstitial stasis that happens. Well, the central nervous system can have this stasis too. Just like other fascial and interstitial components of the extracellular matrix, we can have a buildup of inflammation in these spaces as well, right? And this, if we look at, it's kind of a different representation of the other one that we had of perineuronal networks, that little visual. This is just a different look, different representation of what it might look like. But this is neurological tissue that shows you the interstitial matrix. Collagen is a component, along with lots of other things that are supposed to be supporting it, with other things existing inside, like astrocytes and microglia. Very important for managing our neurological and inflammatory state and hopefully regulating it and not making it pathological, but we might not be great at controlling that piece. The perineuronal nets, which is like the lattice-like network of support around neurons. And then we have the basement membrane, which is supposed to be the protective layer, which we know now things can break through the blood-brain barrier, and having an inflammatory control problem, like autoimmune disorders as well, but also a problem with the structure and barrier itself, like a connective tissue disorder, can make an individual more prone to developing neurological extracellular matrix stiffness as well. This one I just found and it was fun. So again, just so that we can understand, we need to be way more specific with what we're talking about with the individual. So when we're talking about neurological components, there are, and I'm going to tell you, we don't know everything. And I put myself in we. I don't mean it that way. I'm not doing the research. I just read the research. They are coming up with understanding the collagen or the 3D structure components of the extracellular matrix in neurological tissue. This is a really new conversation. The extracellular matrix component has, like I said, has been around since Pishinger, but understanding that the precision that we need to understand around vasculature and neurological structures and other things like that. This is really, there's a lot of work still to be done, okay? But in looking at, so far, in looking at the extracellular matrix and the structural components that go into developing the central nervous system, collagens type 1, 4, 9, and 18 seem to play an important structural role. The brain meninge basal lamina, so layers, we're talking about layers surrounding the brain now, collagens type 1, 3, and 4. The vascular basal lamina, so more of the vascular surrounding components, 4, 7, and 18. And 7 do a lot of barrier protection around our vasculature and other tissues as well. And then the perineuronal nets, collagens type 19, But foreign disease states, with this article, there's more coming out about the perineuronal nets, which I do think are important for the excitability component, which I think that we talked about in just a moment. So just to support that, hey, we're all starting to see this, guys. Like there's something going on with our other structural components throughout the body. It's not just ligaments and tendons. This article, Nicole Frost was one of the articles back, one of the authors back in 2024, talking about neuraxial dysfunction throughout the neurological system. It does such a great job at talking through all of what we should be seeing in our typical presentation, and then what are we seeing in EDS. And part of it can be these mechanical loading problems because there's a difference in the tissue itself. And that can create an inflammatory type of reaction and problem locally. And this is where I tell people, like, yes, it can happen locally. It can cause, especially because we're talking about the stasis with uncontrolled inflammation, chronic inflammation. We can end up with stasis that happens in these areas. And again, we're not moving things like we should. And we end up with neurovascular plumbing problems because of the combination of mechanical changes in the individual, so movement that happens around the neurological tissue. And then we have the structure that has difficulty holding itself up and protecting it from inflammatory changes, so it doesn't. So we get this buildup of inflammation that eventually just clogs the system around the neuraxial components. And this is very important to understanding the presentation of arachnoiditis, Chiari malformation, tethered cord. And the mechanical components that we're talking about with EDS, like the altered movement that we see in certain areas of the spine, could predispose to, that's why we see it up at the cranial base, and that's why we see it down into the lower lumbar spine, is because of the mechanical problems that are more common to these individuals. But they are there because there is this stasis around the matrix that we can't get the plumbing out. So this inflammatory process builds up around the neurological tissue, and we just can't drain it out well without help. So a lot of people can be helped if we understand what's actually happening at the extracellular matrix. And for those who like visuals, please go print out this article. Again, it shows you the neuraxial interactions that we should be seeing. And this is what, like, there's so much that goes on in the neurological tissue and how it talks to other components of the body and how the neurovascular plumbing happens. And then what we see as pathologies when things are not addressed, controlled, or brought back into homeostasis, then we see pathologies pop up. Okay, so I warn people, mostly what I present, like everything that I present, is not my opinion. It's actually not my work. It's already out there and it's available. I just kind of bring it together. However, I'm going to offer my opinion on this because I just haven't seen this out there. But I think it's important for our medical providers to understand and give some validation to the people that we see, is that in understanding now that we're talking about this global organ system problem, it's more than a ligament issue. That's not my opinion. My opinion is that if we understand that it's a filter problem, that we have a 3D structure that's not well supported and it's not filtering out our toxins and inflammatory mediators well, then we have to understand that our current environment is getting worse. It's not necessarily that more of us are developing the genes for these conditions. It is that we are the canaries not in the mine shaft. We are the canaries in literally the world that we have created and modernized with the inflammatory components that are now starting to break down our extracellular matrix and cause chronic illness. Okay, and if we have a connective tissue component, we might see more physical presentation. Yes, we'll see some neurological stuff and cognitive dysfunction as it changes neurological tissue, but we're going to see a lot of this anatomical change in these tissues as well because it's the matrix. Okay, so I do think that more people are coming down with the presentation is because we're challenging more people's extracellular matrix through the inflammation that is around our environment. And I'm talking about not just, we have pathogens, yes, like bacterial loads. And thanks to COVID, we honestly, we really know like, hey, these viral things are a problem. Um, so just to understand, again, it's not one thing, it's usually the combination of all the things a person has dealt with and maybe never fully had help with resolving those inflammatory mediators from strep as a child or, COVID and Epstein-Barr, and they had a mold exposure, and they are sensitive to electromagnetic fields. That's not uncommon. That's not uncommon in an individual because our matrix, our bodies are exposed to all of the things at this point. The difference in these individuals is how their extracellular matrix responds to it. And that's why I try to tell people, look, you can test if you want. I think in some cases it's actually very important. But we have to assume that you've been exposed to quite a lot throughout your life. So let's start going through your story and seeing what you already know that you've been exposed to. And we know this too in working with, I do forget if it was COVID. This is in a talk. If you want to watch that one when it comes out on with Mount Sinai, I did have the article reference, that we're seeing the same pathogens in one individual versus another. Same with mold, right? Like you can find mold in in the people that are living in the same house, in their systems. What is the difference? The difference is actually internal and the breakdown of the matrix that's happening. COVID, actually, the prognosis for COVID is related to the breakdown of the extracellular matrix and the health of the matrix. So it's actually not what you've been exposed to, it's how the body and the matrix is responding to that exposure. And that's why having a structural connective tissue problem is difficult when dealing with inflammation in our environment. Okay, so stiffness is the problem. I've kind of now said a lot of what's on the next many slides, so I am going to fly through this, but I left the information on here for anybody that does want to look up the articles, they want more information for themselves or their doctors. But extracellular matrix stiffness, we actually know is correlated with chronic disease and chronic infections. Okay, and what we know through people that have connective tissue disorders is that they might be more prone to extracellular matrix stiffness. That makes them more prone to chronic disease and chronic infections. Okay, now it makes sense, right? Like it's what we're actually talking about. Yes, it can be ligaments, it can be tendons. Actually, that depends on somebody's genetic components. But from a systems functioning point of view, if we're talking about the interstitial space where inflammatory reactions happen, it's collagens type 1, 2, 3, 5, and 11. And they might find more things. They might, but right now, this is what the inflammation is saying. And then the basement membrane layers that are supposed to be our protective layers where it doesn't get into, these immune cells or pathogens don't cross into tissue that shouldn't be touched. Is collagens type 4 and 7. And again, you can have an inflammation buildup that eventually changes the permeability and allows things to pass through, even if you don't have a collagen type 4 or 7 problem. So individuals that have an extracellular matrix structure problem, again, whether it's proteoglycans, laminins, and this is, again, why it's been so difficult to figure out what somebody's HEDS is because there's so many things that are in the matrix itself. Then those individuals might be more prone to developing the stiffness that leads to chronic dysfunction, if not helped and treated. Okay, just like we see in the fascia, and it's predicted when we talk about neuraxial dysfunction and these plumbing problems as well. Okay, so the blood-brain barrier issues, this is just really to reemphasize the fact that this happens in other areas as well. And we have the blood-brain barrier is actually an extracellular matrix. It has its own composition, and things should not pass it. Okay, but things can pass it if it's broken down enough that things get through, right? And possibly viruses or something that get through a little bit quicker just because of the size of them. But it can lead to more than just this, but just what we're seeing in our population too, this category of excitability, neurological problems, and then changes in structure of the tissue as well, extracellular matrix stiffness. So on one side, when we're talking about those perineuronal networks that should not have pathogens in them, that the environment should be calm and it should allow for normalized conduction between these neurons, that when you actually add these pathogens or whatever it might be into that crosses over into the barrier, then you might be losing what should be a constant, just like the extracellular matrix, it should be constantly malleable and moving and going back from, working on inflammation, and now we're not, and we're stable. And we need the malleability actually in these spaces, and we lose it when the stasis happens. And that causes impairment in function. It kind of turns it off. So when that happens in the perineuronal nets of the central nervous system, from one side of it, we can actually see neurodegeneration. From the other side of it, we can see neural hyperreactivity, which can also be seen as seizure-like activity. Important for our population to understand that it's a simple problem of inflammation has been left uncontrolled in your extracellular matrix and has not been helped yet. Okay. However, how it got there and how we work on it, that's very complex. But the problem is typically this, and I'm minimizing it, right? Trying not to, because those two ends of it are very, very complicated. But the problem itself is interstitial stasis in the perineuronal nets, in the other parts of connective tissue that happens, and we lose function. We lose function in homeostasis, right? So in the central nervous system, if we're talking about whether it's the dura around the brain, or we're talking about some of these mechanically irritated areas like C2 or the brainstem where a lot of movement happens or is supposed to happen, or down lower into the spine itself, when you have this pathogen problem or inflammation problem, in the neurological system, we have the astrocytes and the microglia that jump in and as inflammatory responses. And when they jump in and we don't clear them out, it can actually cause structural changes, that neurovascular plumbing problem in the local tissue. And you can actually have what used to be called glial scarring, more of a border formation. So you have change in the structure of the neurological tissue as what's trying to be a protective mechanism, but it actually causes a change in the mobility of the tissue and inflammation around that barrier protection, um, which correlates very well with Chiari malformation and tethered cord in this population. And that's important. Okay, so astrocytes. I have 4 different series of things I talk about astrocytes and microglia, but just to understand that astrocytes are, part of the inflammatory process that's supposed to be physiological and helpful to help fight something off. And if kind of like mast cells, and if we don't control that reaction, or something happens and it's feels like it's fighting a losing battle, they don't necessarily turn off. And same with microglia as well, which are more the phagocyte part of the neurological inflammation. Um, so astrocytes actually will cause like a pathological reaction if they're overactive in the system. And astrocyte microglia understanding, please, if you're interested in neurological symptoms and presentation and all of that, especially as a provider, you need to go look this up. And just so you understand about the extracellular matrix component, it's very similar to the astrocyte component. Um, for a very long time, up until pretty darn recently, we thought these astrocytes were cushioned for the brain and played no functional role. I think we've now learned that there is not anything in the body that doesn't have a functional component to it, because these little astrocytes are the neuroimmune regulators of the body. Um, and that's huge. Astrocytes are related to neurodegenerative conditions like Alzheimer's, and there's a relation to even autism out there. So astrocytes are really important, but just to understand where we are in science, we just figured out that they're not cushion material, and that these cells that are the most abundant cells in the central nervous system actually function and do something. Um, So if we have blood-brain barrier issues, we can have this disruption of the perineuronal networks, like I was saying. So we have, a pathological presentation of these astrocytes and microglia. So this self-perpetuating cycle of inflammation that happens, and it will change the conductivity because that changes the environment that these nerves are sitting in. So the environment is saying danger, danger, danger constantly. And why that's important again for our population is that this, well, I'll just bring it down to what could happen in our population. It could be other things, it could be, but if we have this inflammatory change that happens in the extracellular matrix that is not regulated in some individuals that carry other genetics and other components and things that have happened to their system, not everybody gets this, but in some individuals, because of that combination, if we haven't handled the inflammatory change that's happened in that neurological tissue, they can end up with seizure-like activity. And that's important because as we're trying to figure out, like, are these people with EDS having seizures or seizure-like activity? It's because the inflammation has crossed into their neurological extracellular matrix and it has not been assisted yet. Okay, for my science nerds out there, MMP9. Now, there's actually other types of matrix metalloproteinases as well. But just to understand that MMP9 does a lot in the body. It's actually they break down extracellular matrix. So this is actually part of the healing process that's supposed to be helpful in remodeling. So MMP9 and MMP2 and 9 are more present in the neurological system, but MMP9, and I keep saying this, you'll hear why. So it has a lot to do with extracellular matrix stability and also remodeling and neuroplasticity within those perineuronal networks. So the reason why I say this too, again, is just to confirm, hey, this is what we're seeing. This is a breakdown that happens. The cycle of inflammation builds up. The inflammation in it of itself will actually cause a breakdown of the matrix. The matrix was already not that great to start with. It needed a little help. It didn't get it. So now we're caught in this self-perpetuating cycle of interstitial stasis and breakdown of that matrix, which keeps somebody in that pathological state. Okay. Oh, and MMP9 has been indicated at elevated levels in individuals that were reported to have HEDS. So there it is. Okay, I thought I might have it somewhere. So again, just to say, hey guys, we're seeing this. Like let's put it all together. We're seeing that these individuals are having when inflammation is added, and that's where I think the missing piece is that this doesn't just happen to somebody just because you have an altered connective tissue structure, a 3D structure, doesn't mean it's going to fail on you. We have to add chaos to it in order for it to start to fail. And somebody needs to help us with that chaos that's happening. And it is absolutely possible. It's about stabilizing the inflammation in the interstitial space and working on the pathogen itself, whatever that might be. So many different inflammatory mediators that can be part of it, but we can't give up because there's lots of things that are in the body. So we have inflammation, we have the trigger of the inflammation. We have to work on both of those. And then when we do that, we step back and we see what's left over. And then what does that individual need more specific help with? And what you see when you actually work on the inflammatory pieces, you actually might see that there's still autonomic dysregulation because it's that feedback loop. So it's been reprogrammed. And now we have to program it back to functioning normally. We might see that somebody actually does have, some upper cervical instability that was feeding into this brainstem compression that was exacerbated by adhesions from the extracellular matrix inflammatory changes. So they do need injections, and that could help with the upper cervical portion. So I tell people, look, when there's so much inflammation, we have no idea what surgery, procedure, or if you need any at all. It is too foggy. We can't see what's happening. You have to clear out the fog to be able to see the path. That's really important. And there might still be things left over. So I'm trying not to say like we can prevent surgery for everybody. Not necessarily, but for some we can for sure. And just to support again that the crossover that we're seeing, this is from a McConnell article in 2019. Um, when you have an increase in this blood-brain permeability, you can have all of these things that happen, right? Including that seizure-like activity, right? I also think this is a really funny little graphic because you can see an increased blood-brain barrier permeability. For those of you that read the CSF leak article on HEDS, you can see in theirs too, they say, oh, change in blood-brain barrier permeability because of extracellular matrix dysfunction. Yes, you can have increased blood-brain barrier permeability because you have altered extracellular matrix and inflammation has been added to it, right? So you can see biological insult, infection, inflammation, physical insult that might happen, even a concussion for this population. All of that can increase the permeability and let things in through the blood-brain barrier that will disrupt the nervous system. So it's just like a double whammy when you have something that puts you at increased risk for this. And then you can have all of these things that happen when the astrocytes start to take over. So on the left-hand side, I giggle because it's like, oh, resolution, healthy brain, so easy. And I over and over, I keep saying, I'm trying to explain what is happening, but through the explanation, this is difficult to figure out how to help somebody. Please don't think that I'm saying, oh, it's inflammation. We'll just get rid of the inflammation. Very difficult to figure out what an individual needs, how to work on it without flaring things up. But just it'll make you giggle. Just go ahead and just give them a healthy brain and be better. Just another graphic to talk about the astrocyte portion, that neurological cell that helps with the communication between the neuroimmune system. Again, showing you, hey, we kind of have two different things that can happen. And I just think it's so interesting because we see that the scar formation that's on that right-hand side, reactive astrogliosis, to the right, and then severe scar forming. Now, this is not written for our population, so that's not to say somebody has, or it's actually from trauma or stroke. It can be from a combination of this systemic inflammatory change that lights the neurological tissue on fire, causes this stasis to happen. And if you add trauma to it, and I can't tell you how many stories I've heard of this, where maybe something was happening in my nervous system and then this physical trauma happened and then I had tethered cord. So I do think that the physical piece needs to be worked on, but that can be really confusing to see exactly where that is in the body, again, with all the fog that's happening. So you have to work on the inflammation, you have to work on the actual anatomical piece as well. And not going down this rabbit hole, but I just do want to say it quickly that from that point of view, the best things that I have seen to work on this type of neurovascular plumbing problem and neurovascular stasis that happens is either fascial counterstrain that specifically works on interstitial stasis, or it is microcurrent. However, the microcurrent is going to work only in tandem with removing the inflammatory process and the pathogens in this population. Okay, so that's important. In and of itself, it's not going to be long-term helpful. And then on the left-hand side, you can see, so reactive astrogliosis, they actually change their morphology, and that's where you get like the stiffening actually in the tissue. And then the astrocytopathy, that is more of this change in excitability, and you can see the epilepsy. And then just interesting, you can see like Alzheimer's disease, major depressive disorder. So that's why I try to tell people I understand that we have the biopsychosocial model, um, and they can all coexist, but they're also separate entities. I talk a lot about biology, neurology, and psychology, and they are three distinct problems that can all affect each other. But it's really important to understand that it's not always 100% linked with psychology. I just think that a lot of people have that idea of it's always linked because they're always connected, and they are, but you can really have a biological or neurologically driven problem that leads to, and we know this too, there's other papers out there about the mast cell changes or degranulation with stress hormones, the corticotropin releasing hormone that can actually, and you watch how it kind of filters down this beautiful chart that they made, and it can, because of the inflammatory processes that trickles down, it can lead to neuroinflammation that worsens symptoms with autism, ADHD, OCD. That is a biological, neurological problem that leads to some of what we consider psychological changes. So just to understand that we still need a separation, because we can work on psychology all that we want, but it's not necessarily going to have as much impact for those that are dealing with inflammatory changes if we go for the biological and neurological piece. Okay, so border formation. Um, I kind of talked about this before, just to understand that you can have a change in the actual structure of the neurological sheaths, these protective sheaths that are around neurological tissue. Okay, so they are these border formations that are supposed to be protected in nature, but if we don't remove the trigger, they will stay. So, and we see this from trauma, infection, autoimmune conditions, as per this article here. But again, autoimmune is almost a little bit redundant now if you think of it is a different thing that's happening. And there are some people that have the lucky genetics of having an overlap between autoimmune and connective tissue, because autoimmune means that you have difficulty with your inflammatory responses in the matrix. So that's more of like the immune control, inflammatory control within the matrix. And if you also have a 3D structure problem and an inflammatory control, that is also double whammy. And there's plenty of people out there that have the combination of both. So again, inflammatory problem that happens, we can't clear it out of the local neurological tissue, and it can actually become sticky and in this stasis or stiffness that occurs, and you're not going to get the mobility of the tissue that you once had. And this happens in neurological tissue. That's why cord tethering, arachnoiditis, Chiari malformation, for those who don't know, is adhesions. They're adhesions. So we've got to work on the inflammatory process and these adhesive or stasis changes that happen. And the glial scarring, it's again, inflammatory process. The astrocytes come in, they're not well controlled. They continue to puff up. Morphology wise, they actually change. And when they lay down, they cause this buildup of it's like a thickening of the tissue, and now we're not getting the flow through it. We're not getting, it's kind of the stasis that happens because of the inflammatory reaction in the neurological tissue. And this is just if anybody wants to read this, to kind of look at it, it talks about central nervous system lesions. But again, just to look at this, and this is obviously not exactly what it looks like, but it just shows you like, yep, there's a fibrotic scar that forms around injured neurological tissue. And then you have this border around it, and it's actually the border around it that it stays, that is constantly trying to remodel because the trigger has not been removed, the inflammation has not been removed, the threat has not been removed. So it will continue to remodel because it's not controlling the inflammation. And that's where the constant pain and irritation around the stiffened tissue, tethered cord, comes from. So just to understand, like we're still seeing an extracellular matrix dysfunction, neurovascular plumbing problem. It comes from uncontrolled inflammation systemically in the body. That is why when you look at the neurological phenotype of HEDS, that when you look at that group, like they have all of the things, it's because this is a system-wide problem, and we might see it hyper-focused at the brainstem and at these mechanical places of dysfunction from, yes, hypermobility. But it's, again, if you don't work on the inflammatory problem, it will not change what is happening at the local neurological tissue. It won't. And if you remove the tissue, the problem is still happening elsewhere in the body. So for those, that's why now if we're having life-threatening problems, you go have that procedure done. We'll deal. This is long-term management strategy. But when we're talking about, and this happens around vascular tissue too, extracellular matrix stiffness. So when you have changes in the extracellular matrix around vascular tissue, it affects the stability of the blood vessel itself, which can be part of the systemic compression problem. And that's why you see multiple things popping up, is because this is an extracellular matrix problem. It's the whole organ system. So if you have a vascular extracellular matrix stiffening in one area, you're probably going to have to some extent throughout the body. And if the person has additional anatomy that feeds into compression, then you can have those presentations of multiple vascular compressions. It's the same idea. We're just talking about a different tissue, the extracellular matrix, that does not have good plumbing. It hasn't been helped with inflammatory regulation. So what I tell people is that if we have the time, we better have exhausted everything possible for controlling inflammation and restabilizing the interstitial matrix before we consider stenting, cord releases, and things like that. Not everybody can escape it, but for a lot of people, to at least give them the best outcomes after a procedure or maybe prevent one, you have to work on this piece. It's a systemic problem. It's a whole organ problem. We just don't talk about it enough from that lens. Okay, so just again, just talking kind of about the overlap. I already did this, but the tether cord presentation, Chiari presentations are adhesive in nature, or interstitial stasis in nature. It's the same conversation that we're talking about. This just happens in the neurological tissue, so we have to make sure that we stabilize the inflammatory process and support the inflammatory process, clearing it out so that we can have neurovascular plumbing, so the astrocytes calm down, the microglia calm down, and then we have mobility again in that neurological tissue as things start to settle down. And again, it happens around vasculature as well. Here's a Chiari malformation reference in case anybody was like, what do you mean adhesions are Chiari malformation? They are. Here's all of the adhesive type changes that happen. Some of them, yes, like webbing at the obex, tonsillar gliosis. That is a little bit less often. But if you look at arachnoid adhesions and thickening of the tissue, this is exactly what we're talking about. You got to work on inflammation, guys. Sorry. A visual for you. Some of you are like, maybe the astrocytes pop up. Um, I did go through my own history of tether cord and did work through it and a lot of neurological stuff. And the reason why I put this in here is because I feel like this is what I felt like. Felt like my neurological system was just puffed up. And that is the morphological changes that happen with astrocytes. You can see on the left-hand side, that picture is of healthy astrocytes. So ones that are not currently pathological, they're just kind of doing their thing. They've got a flow going. But when you look at so we go from physiological to pathological on the right-hand side, you can see how they puff up and the space doesn't change. You don't have a change in the space that's allowed for these astrocytes to exist. They just puff up. And a lot of people are like, that's exactly what my neural tissue feels like. It feels like it's puffed up and there's not the room anymore to have the movement of it. So that is part of the reactive astrogliosis, is of the inflammatory changes and the changes in like the neurovascular movement. Okay. In regards to this, actually is talking about like the astrocyte puffiness. The morphology of the astrocyte is returned to normal once the stimulus was removed. Okay, and this is like on the lines of the glial scarring as well. Now, this is back in 2013 when I just started to realize that astrocytes or something. So there's probably, I hope there's going to be more research that comes out, but it's just important to understand that we live in a world where we treat symptoms. It's just how our medical world has developed, to be honest. However, if we would like to return an individual back to homeostasis, we have to remove the trigger that is causing the problem. So, in other words, if an unhealthy home environment that's constantly causing stress is causing the inflammation, we need to work on that. If it is a history of COVID or Epstein-Barr, we've got to work on that. If it's a history of poor food choices and that's causing the inflammation, we have to work on that. So, I have not met a person where it's one thing. Okay. Again, this is like a whole matrix problem, but we have to remove the stimulus. So I know that there's a lot of medical that they're so brilliant, work on symptom management, and there's very little work done on the stimulus part. What is actually causing the mast cell component? What is causing the mast cells to be angry? Um, as you can, like, they exist in the extracellular matrix. So as you can see, if somebody's matrix becomes dysfunctional, they will become confused and they would be part of this self-perpetuating cycle of inflammation. So it still comes down to, even with a dysfunctional structure system, what made it mad in the first place? Something came into that space and caused this inflammatory cascade. That is what needs to be worked on. And this is just my little, I just made a little like overlapping little Venn diagram. Yeah. So if you have a shift in the blood-brain barrier and things are actually getting through, and this can actually be from chronic inflammation that consistently breaks it down, and or from a genetic risk. So having something that affects the barrier basement membranes themselves genetically, or the interstitial space that can break it down further over time. All of those things can contribute to a shift in the blood-brain barrier, allowing things to come in. And then you have this inflammatory reaction that can happen, which can be from a plethora of different things. And somebody can also have mast cell dysfunction genetically. They can also have astrocyte and microglia dysfunction. And then when they all meet up in the middle, you have this self-perpetuating cycle of inflammation that's really, really difficult to break up, but you can break it up. You just have to go through each one of those pieces and support the individual. But again, you've got to remove that trigger, that the source of the inflammatory process itself. And then this one I just threw in just to remind everybody that we're still like, we can talk about this conversation in so many different tissues. This particular one talks about in the meninges, lymphatic drainage problem in the meninges. It's the same thing. So when we look up in this space, somebody will end up having difficulty draining meningeal lymphatics because there's a stiffness that develops from inflammation. So if we develop stiffness, it will plug up our plumbing and we will not have that good recycle mechanism to get inflammation out. So this can happen at a lot of different tissues. I think that we need to talk about it in neurology and vasculature a lot more, and how the extracellular matrix communicates with neurological tissue and vascular tissue. I always put this one up on, like when I talk to medical providers too, and I always say, hey, if your brain works like this and this excites you to see this, you're going to do great working with people with EDS. This is spiky leaky syndrome. Okay, so this is the Maxwell article from 2024, and I just love this. This is how my brain works. This to me is like my happy place. The reason why I have this up here is to once again say that something is so simple as saying somebody has an intracranial pressure problem, just like we're saying somebody has tethered cord or somebody has seizure-like activity. This is actually what it looks like when we're talking about how we got there. There are a lot of contributing factors. I'm talking about inflammation. There still is, as this article points out, there's anatomy that can make this worse. Yes, there is. We may or may not have to work on it, because if you look all the way up at the top there, okay, genetically susceptible hosts, we've talked about that, extracellular matrix dysfunction. Okay, yes, chronic poor head posture, like we look into that. Look over to the left, environmental trigger. So this is where we're recognizing inflammation plus extracellular matrix dysfunction equals very difficult to exist in our modern world. Okay. But again, I didn't want to try to simplify this for everybody. You can laugh along with me. I know it's not simple, but to explain it in a way that to say like, hey, this is a simple inflammatory problem, but this is what it can cause. This is what a simple inflammatory problem can cause in the human body. I don't want to simplify that. This is very complicated. This is so layered for each individual. But what I want to say is that the problem of extracellular matrix dysfunction plus inflammation equals bad. Okay, and I don't think that we're working on the inflammatory piece as much as we should with these individuals. And I always remind people, when you see your surgeon, when you see somebody that wants to do a procedure on you, that is what they are trained to do. And typically they want to help. I'm not saying these are bad people and they shouldn't be doing what they are doing, but I don't think that a lot of these individuals understand the complexity of the interaction of inflammation in the extracellular matrix and what it does to the tissues of the body. So I'm not trying to demonize any procedure. And I always say to people, your timeline is perfect. It's always going to be right, because we have no idea what we're doing, because this is what happens in the human body. It's very difficult to figure out everything perfectly. So we just want to make sure that we start to understand this more global problem before we start working on what seems to be like, oh, it's all the things now. It is your extracellular matrix that isn't controlling inflammation anymore. Okay. Lots of references. I cheated. They're not all, they're not all used in here. This is, but if you want some really good references, these are amazing ones. And there's actually a bunch in here about the viral component, the COVID-19 and extracellular matrix dysfunction. If anybody wants to go down those rabbit holes, I had done a talk at Mount Sinai on that. So I just left them in there because I didn't want to organize and cut and paste. Sorry guys, but good references. And all the ones that I had in there for you are in the references if you do want to cross reference those and look any of those up in particular to look into them for more details. But thank you for listening. I always think I'm going to do this in 30 minutes, and I don't. But this is really important to me understanding this because, like I tell people, we're not going to cure somebody of an extracellular matrix alteration, risk factor, you know, genetic component. But if we understand how to support them better when inflammation is something that can be detrimental to their system, I think we can put a lot of people into remission and better control of their symptoms, at least. So, this is really important and near and dear to my heart. And I know this is really long, but if you think of any providers that might benefit from it, please send it their way. And thank you so much for listening to all of this. I do appreciate you. Bye, guys.